All right, now let's take a look at point B. Part B. Suppose the initial upward velocity of a second ball is half that of the first ball. The initial height is still 6 feet. So we're going to take our original equation and adjust it a little bit. Remember, we keep the negative 16x squared for gravity, plus this number was 80 up here. You can't see it, it's off the screen, but it's going to be half that. So we're going to change that to 40x and keep the initial height at 6 feet still. So there's our new equation. Determine a reasonable domain and range and an appropriate viewing window. So if we kept the same viewing window, let's just make an adjustment. What do you think is going to happen to this graph? Let me get rid of this. It's going to be taller, shorter, different? Quite a bit shorter. And its domain is a lot different too. So let's think about the domain from 0 all the way to that point, which is more than 2 and less than 3. We need to find out what that point is. So I'm going to use second trace 0, go to the left of that point, go to the right of that point, and hit enter. So about 2.64 seconds. So the domain is between 0 and 2.64 seconds. The range similarly starts at 0, we're not counting the stuff underneath, and goes up to the maximum. So it's 0 to, that we have to calculate. Second trace 4. Left bound, make sure you're on the left of the maximum. Right bound, right of the maximum, and hit enter. The maximum is about 1.25 feet. So 1.25 is that range. Oh, that's seconds. 31 feet. Sorry, I was looking at X instead of Y. Y is 31.